Hi everyone. These are the answers for the 7.1 to 7.3 quiz review. Your quiz is on Monday, and I broke them into a couple of parts. So I just scanned the quiz in and then or my answer key to it, and I just thought I'd run through it for those things that have questions. So these are the first three questions. You can see the answers there, and then I just jotted down what I thought, how I think about doing them. So the idea here is that you do these without a calculator. You can use your handy dandy table of values to do some of these. So for the first one here, I want you to think 16 to the fourth root. This, remember the denominator is the fourth root. So it's 16 to the 1/4, or the fourth root of 16, which is 2. You can find that on your table. And then think 2 to the 5th, because remember you can break these up. You can actually do 16 to the 5th power first and then take the fourth root of that, but I think it's much, 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 much harder because I don't know what 16 to the 5th root is, but I do know what the fourth root of 16 is, 2, and I do know that 2 to the 5th is 32, so that's how you get the answer for that. For number 2, the fourth root of 16 is 2 again, so the same thing with as this problem, only you have a negative. So it's 2 to the 5th power, 32, and then the -1 is what you have left, which is 1 over 32. So the answer is 1 over 32. And then number 3, it's the cubed root of 8, which is 2, and then 2 to the -2 power. Well, I do 2 to the 2nd power first, which is 4, and then 4 to the -1, which is 1/4. So it's really 3 steps that you're looking at there. When I was looking at your practice quizzes the other day, a lot of people, when they saw the negative here, they were making the answer negative. And remember, that's not what you do. Oops. You just do, you just flip it. Okay, so then the next group of problems, these are use your calculator. And I went to the 2 graphing calculators that I have on my website, and I couldn't really figure out an easy way to explain them to you. So I searched and I searched and I searched and couldn't find a good one that I liked. Then it occurred to me, why don't you just use Google? So I wanted to show you this first one, 25 to the -4/3 power. If you don't have a calculator at home, you can go to Google and see if I can find it here for you. I put it in here, and you can type into this bar right here, 25, and then to the, use the caret, 25, let's see what comes up here. This is great. 25 to the 4/3 power. Put that in parentheses, and then look at what pops up. Now I can't remember if that's exactly what it was. So the answer pops up no matter what you have. So then it says round to the 3 decimal places, so it would be here. So let's go back to my PowerPoint, and it was -4/3. So let's go back to Google. And put in -4/3, negative, and then look at it, just automatically changes it. So how cool is that? So the answer should be 0.014, because you look at the 3, this is bigger than 5, it's bigger than 4, it's 6, so you're looking for 5 or bigger, and then this gets bumped up. So it should be 0.014. If I go back to my PowerPoint, it's 0.014. So that's good. So that's what you can do for all of these. So if you don't have a graphing calculator at home, then that's okay. That's how you do them. Here are the answers. I'll let you check them. Now these, it works a little bit differently. I wrote out here under number 7, the way that you would put that into Google or in your TI at school, this works for both of them, is 4,983 raised to the 1/7 power, because remember the 7th root is the same as the 1/7 power, and then hit enter, and you should get 3.375. This one would be 4,285, has to be in parentheses. Well, it should be in parentheses, raised to the, this has to be in parentheses, 3 divided by 4, 3/4 power. Then hit enter, and you'll get that. And then think to yourself, does that make sense? And I think that it does. 3/4 power means less than 1, so that means less than this whole. And I think that's it. Okay. The next part. Somebody's knocking at my door. Hang on. Okay, sorry. So these problems here, there's lots of different ways to simplify them. We're going to go through a couple of them, and you can see all the rest of the answers. I tried showing the work for the ones I thought you might need it. So this one here, the first thing you have to do is simplify this. This is 8 times 5. That's what 40 is. So 8 times 5, the cubed root of 8 is 2, and then we're left with the cubed root of 5 under the radical. Then times 4 cubed roots of 5. And when I multiply these two together, I get 8. And then when I multiply these two together, it's still the cubed root, but I could put the 5 times the 5 under the radical. And so that's cubed root of 25, which is not an integer, so we leave it like that. This one, I put under 1 cubed root. And then I simplified it. I got 1 over 27. Well, the cubed root of 1 is 1. The cubed root of 27 is 3. So my answer is just 1/3. You could have also split this up into the cubed root of 2 times the cubed root of 27, and then the cubed root of 2 would cancel top to bottom. Two different ways to do it. There's probably a third. This one, look at what I did here. I was thinking, you know how you need to have 5 numbers of the same in order to take that out of the radical when it's a 5th root? So I thought that 9, I wanted to see 9 is 3 times 3, and 81 is 3 times 3 times 3 times 3, or 9 times 9 is 81 is what I was thinking. So when I wrote it like this, I could see that there are 1, 2, 3, 4, 5, 6 3s. So one of those 3s I could take out. That was the 5th root of 3 times 3 times 3 times 3 times 3. And then the last lonely 3 was left there. And so I wrote it like this. And in the denominator, there was one of the exact same things. So those whole things cancel out. I'm left with just 3. For number 12, same base. I add the exponents. I need common denominators. So I would get 4 twelfths plus 3 twelfths, which is 7 twelfths. That's how that one comes about. In your calculator, you can type in your calculator in parentheses 1/3 plus parenthesis 1/4. Close each of the parentheses. Hit enter. You're going to get a decimal. Then you can hit math frac, and it'll show you that it's 7/12. So that's the way to cheat on those. Number 13, you're going to take the square root of 64, which is 8, and then the square root of x to the 12th, which is the same thing as x to the 12th to the 1/2 power, which is 12 times 1/2, or 6. Or you can think about it as how many pairs of x's are there when you have 12 x's? 6. So the square root of x to the 12th is 6. Number 13, we're going to raise each power to a power. So 25, I did 25 divided by 5 is 5. 5 times 4 is 20. That's where that came from. And same thing down here. 20 divided by 5 is 4. 4 times 4 is 16. Power to a power, you multiply. These power to a power, you multiply. So when I multiply -2 over 5 to 15, the 5 and the 15 cancel and get 3. 3 times 2, -2 is -6. And when I take 1/3 times 15, I get 5. So this is here. And then the negative exponent, you have to move to the denominator. Number 15, you can think about it as this raised to the 1/3 power, or 6 times 1/3, which would be 2. So x squared. And y to the 30th to the 1/3. So it's 30 times 1/3, which is 10, which is where that comes from. And number 16, this is 1. So I wrote that out first. And then I thought 3/2 minus -5/2. That's the same as 3/2 plus 5/2. They have common denominators, those fractions do. So 3 plus 5 is 8/2. 8 divided by 2 is 4. That's where that came from. Oh, so this should have a 4 right here. Oh, I'm on the phone. Okay, I'm back again. Well, it's kind of funny. This must be why I did this with my kids in bed last time. Okay, so now number 17, the 7th power. So all I do is I just do 14 divided by 7 because it's to the 7th power. So it's the same as 14 times 1 to the 7th. So 14 divided by 7 is 2. 21 divided by 7 is 3. That goes here. And then the denominator, it's 35 divided by 7, which is 5, but it's a -5. So that bumps it up to the numerator. Okay? So that's that. This one, the 5th root of 5, those are the same, and so all you have to do is add the coefficient. So it's 12 times the fifth root of 5. 19, same thing. They're both sixth roots of 9. This is a 1 as a coefficient here. So 1 minus 4 is negative 3 sixth roots of 9. And number 20 is, let's see, negative 1/2 plus 1 and 1/2. So when I add those together, I get 1. And lazy mathematicians don't have to write the 1 down. So it's 1 cubed root of 10, or just the cubed root of 10. Number 20. This one's a little bit different because I know what the cubed root of 8 is. The cubed root of 8 is 2. So it's 18 times 2 or 36. And the cubed root of 27 I know. So that's 3 times 3, which is 9. And then 36 minus 9 is 27. Number 22. If I add the coefficients here, because they're both the fifth root of 8, I get 4/5 times the fifth root of 8. Okay? Hopefully that helps. If you have any questions on these, send me an email. I can try to re-explain them a second way. I think that's it. So now on the back, these are the composition, and these look a little bit messier. So let's see what we can do. Determine the domain for each after you put these together. So we're going to subtract the first one here. So when we add or subtract, just like the last thing, I write out the first one just as it is, 16 minus x squared. Write out the second one, 4 minus x. I'm subtracting them. So I just switched the signs. I went plus and minus, and then change the sign, it becomes positive. Now you just put together the, there's negative x squared first, then an x plus x, then 16, 16 minus 4 should be 12. So 12, I lost that in here. So it should be negative x squared plus x plus 12 right here. And then the domain, I can put any number in for x squared, any number in for x. When I put them together, I can put any number into this, so it's all real numbers. And then for b, I write them out this way. And what I don't like is I don't like on this thing that I can't change that to a 12. That's what I'm all huffing about. I can't figure out how to change that. Okay, so just remember, negative x squared plus x plus 12. Hopefully you're listening and not just looking. Okay, number B, letter B, is multiply these together, use the distributive property. This times this is negative 4x squared, and then the outside is negative 16, and then the last is positive x to the third. Then I rewrote it from greatest exponent down this way. So hopefully that one looks good. Then I can put any number in here, any number in here, and there's no restrictions here. So this is all reals also. Now I'm going to jump down here. This is where I added 23c, because we added on find f of g of x. So when I do this, where there is an x for the first one, see how this is 16 minus an x squared? I put parentheses literally on my paper first. Then I fill into the parentheses what g of x is, 4 minus x. Then I solve it. So the 16 comes from here, and then the minus, and now 4 minus x squared is 16 minus 8x plus x squared. So that's all in there. Then so you're going to subtract. So now this gets switched and this gets switched, and the 16s cancel out. So you're left with negative x squared plus 8x. Okay? Now, number 24. Let r of x equals 2x and s of x equals x to the third minus 3. Find s of r of 2. So I work backwards. S of r of 2 I do first. See this over here? This means I put 2 in for x in the r of x equation. So 2 times 2 is 4. So r of 2 is 4. So that means I'm going to put 4 into s. So the inside tells you where to start. Put 2 in r, then put that answer in s. So when I put 4 in s, it's 4 to the third minus 3, because I'm using this. So it's 64 minus 3, or 61. For this part, you don't give a domain because you're just evaluating. Okay? Number 25, it's the same thing. Going to start by putting negative 1 in the s function. So that means negative 1 to the third power, which is negative 1 minus 6. That gives you negative 7. Now it's r of negative 7. I wrote that here. So now I'm going to put negative 7 into this. Negative 7 squared is 49. 49 minus 3 is 46. So that's how you do those. I think that's it on this one. The last couple,